Good afternoon, everyone. So I am Generose de la Serna, BS Ed English, and I am your presenter for this afternoon. So in today's video, we will learn how to get the mean of an ungrouped data as well as the weighted arithmetic mean. So in today's lesson, we will define mean as a measure of central tendency and how to compute for mean of an ungrouped data. So are you ready? Let's begin. So before we start, let's define first the mean. So mean is otherwise known as average, and it is symbolized by this following symbol. So we have the X bar for the mean of the sample, and this Greek letter mu for the mean of the population. It is the most reliable measure of central tendency because it considers all the data sets such that if there is a changes in one data, then the mean is already affected. Furthermore, a mean is one of the important math concepts. Mathematics often deals with data sets or the collection of groups of numbers. So mean is also considered as the average. So the concept of mean is to get the value of the data sets. So to understand more, let's try this sample. So we have the numbers 1, 3, 6, 8, and 7. So that's what we called the set of data. So for us to get to know more how to get the mean easier, let's try to compute this one. However, mean is a combination of addition and division. So what we are going to do is to add all the data. We have here 1 plus 3 plus 6 plus 8 and also plus 7. So adding all of this data, we will arrive to the sum of 25. So next, we divide this number into 5 equal parts because the data involved is 5. So since the sum total is 25, we will divide it into 5 equal parts. And then we will arrive to the sum of 5, or our mean is 5. So for you to understand how to get the mean of an ungrouped data, let's have an example. So solve for the mean of the following data sets. Our problem is, consider the scores of 70-item mathematics examination test taken by 15 students who majors in mathematics. Alright, so to compute the mean of an ungrouped data, we can use this formula. So we have mean is equal to summation of x over n. Alright, so the summation of x here is the sum of all data. Okay, and the n here is the number of data involved. Alright? Again, so the summation of x is the sum of all data, and the n here is the number of data involved. So, for you to understand more about this, or about on how to get the mean of an ungrouped data, so let's have an example. So, if you have pen and a piece of paper, so you can try while watching this video so that you can follow. Alright? So, let's start. Okay. So, the situation here is the solve for the mean of the following data sets. Alright. So So we will find the data of this, or we will find the mean of these data sets. Alright. So first, what we're going to do is to list down all the data that we have. We have students as our N. And scores are X. Alright. So based on our data given, we have 15 students who responded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Alright? So the scores are 70, 69, 68, 67, 66, 65, another 65, 64, no, another 65, and then 60, 59, 58, 57, 56, 55, 53, and 50. Alright? So, for summation of X, it just means we will add the gathered data. So, let's substitute. We will use this formula. Mean is equal to summation of X over N. Here is our formula. Okay? So first, what we're going to do is to add all the scores of the student. So we have 70, 69, 68, 67, 66, 65, 65, plus 60, plus 59, plus 58, plus 57, plus 56, plus 55, plus 53, and plus 50. Alright? So, our N here is the total number of students, whereas 15. Okay? So, here is our denominator. So, what we're going to do is to add all this data. So, we will arrive, so adding all this data, so we will arrive to the sum of 918 divided by the total number of respondents, which is 15. Alright? So, our given here is summation of X is equal to 918. Total number of students is equal to 15. Alright? So, now let's find out what's the mean of this data. So, mean. So, what we're going to do is to divide. So, 918 divided by 15. The total, we will arrive to the sum of, or the total mean of 61.2. Alright? This is our mean. Alright, so based from our computation, the summation of X is equal to 918, our N is 18, and our mean is 61.2. Alright, so to check if our answers is correct, we should bear in mind that the summation of X is equal to N of mean. Alright? Okay. So, let's try checking if my answer is correct. So, let's multiply. Our N is 18 multiplied by our mean, which is 61.2. Alright, all we have to do is to multiply 18 multiplied by 61.2, and the result is 918. So, as you can see, the result is equal to the summation of X. Therefore, our mean is correct. Okay? Now, let's discuss and find out the process of how to get the mean of weighted arithmetic. So, before we dig deeper, let's define first what is weighted arithmetic mean. So when we say weighted arithmetic mean, it is a measure of central tendency of a set of quantitative observations when not all the data or the observations have the same importance. Alright, so the weighted arithmetic mean is equals the sum of the observations multiplied by their heights divided by the sum of their weights. So for you to understand more, let's have our example. In getting the weighted mean, we consider this formula. So we have mean is equal to summation of f, which is the frequency, the x, which is the weight, over the summation of f, which is the respondents tested. Alright? So, let's try to have our own example for you to understand more about and how to get the weighted arithmetic mean.
Solve for the weighted mean of the following data sets. So our problem is, how sufficient are the sanitary facility at Lagao National High School? So suppose that there are 225 high school students, 50 who will voted 5, which is very much sufficient, 50 who voted 4, very sufficient, 50 who voted 3, sufficient, and 50 who voted 2, fairly sufficient, and lastly, 25 who voted 1, insufficient.
Okay, so let's try to solve the problem given using this process. So, we have here the mean is equal to the summation of f on x over the summation of f. Okay, so let's start. What we're going to do is to arrange all the data. So we have f sub 1 f sub 2 of x sub 2 f sub 3 of x sub 3 so on f sub 4 of x on 4 x sub 4 rather and f sub 5 on x sub 5. Alright? So now, over f sub 1, which is our frequency, f sub 1, f sub 2, f sub 3, f sub 4, f sub 5. Okay? So what we're going to do now, so again, the f sub 1 here is f sub 1, so on and forth, stands for our frequency, and also the x sub 1, so on and forth, stands for our weight. Alright, so over the frequency, which is the f sub 1, sub 2, sub 3, sub 4, and sub 5. So what we're going to do is to add all the frequencies. Alright, so we have 50. So we have 50 who voted our x sub 1, which is 5, added by 50 again, our f sub 2, Who voted for? Added by 50, RF sub 3. Who voted 3? RX sub 3, which is 3. Added by 50 again, RF sub 4 of X sub 4, which is 2. And also RF sub 5, which is 25, and RX sub 5 is 1. Okay? Over the total frequencies that we have, which is F1, 2, 3, 4, and 5. So we need to add all of that. So F sub 1, 50, added by F sub 2, F sub 3, F sub 4, and F sub 5. Okay? What we are going to do is to multiply RF on X, meaning 50 multiplied by 5, so we have 250, added by 50 multiplied by 4, we have 200, and our 50 multiplied by 3, we have 150, so on and forth. So we have here 100, and 25 multiplied by 1, we have 25. Alright, over, we need to add all of these frequencies, F sub 1 to 5. So 50 plus 50 plus 50 plus 50 plus 25 is over 225. Okay. So, what we are going to do is to add all the summation of F on X. So, 250 plus 200 plus 150 plus 125. So, we arrive to the total of 725 over our frequency 225. Okay, now let's find out what's the mean of this problem. So, what we're going to do is to divide 725 divided by 225. So, we arrive to the total weighted arithmetic mean value. You obtain 3.22, which happens to be sufficient. Alright. Sufficient. And here is our weighted arithmetic mean. We can also try using this different method, and I think this method is much more easier than the first. So let's try to find out. So what we're going to do is to create a table. Okay, so we have here our frequency. So we have our weight and the summation of frequency and weight, which is the F on X. Okay. So, what we're going to do is to create a table. Okay. So, F sub 1, we have 5. we have 50. Our F sub 2, we have 50 again. F sub 3, 50. Sub 4, 50. And then the sub 5 is 25. Alright, so our frequency, or weight rather, so we have 5. X sub 2, we have 4. X sub 3, we have 3. X sub 4, we have 2. So X sub 5, we have 1. Okay, so what we're going to do is to multiply our F on X. So 50 multiplied by 5, so we have 250. Same process. We have 200. 50 multiplied by 3, 150. And 50 multiplied by 2, 100. So 25 multiplied by 1 itself, so 25. Okay. So, the total is, we need to add all the frequencies. So 50 plus 50 plus 50 plus 50 plus 50. So we will have the total frequency of 225. And also, we will add all the F on X. So, we have 250 plus 200 plus 150 plus 100 plus 120 plus 25 rather. So, we will arrive to the total of 725. And this is our F on X. Now, let's substitute using the same formula. So we have mean is equal to the summation of F on X over the summation of F. Okay, so now what we are going to do is to so the summation of F on X is, we have 725 over the summation of F, so we have 225. Okay, you still follow? So, what we're going to do now, same process, 725 multiply or divided by 225. So we will accumulate the total, or we will obtain the total arithmetic mean value, which is 3.22. Alright? Which happens to be sufficient. So here is our weighted arithmetic mean.
Therefore, the above mentioned problem, so the weighted arithmetic mean value obtained 3.22. So this indicator shows that the sanitary facilities of Lagao, or the facility of Lagao National High School, is sufficient. So that's all for this afternoon. So that's all for my discussion, and I hope you learned something. And thank you and goodbye.